Imagine this. It's a quiet night in late October 2025. The world's telescopes hum softly, their lenses pointed not at Earth, but beyond the sun, towards something newly emerged from the blinding glare. Somewhere, deep beneath the calm voices of mission control, a message moves through encrypted channels. The International Asteroid Warning Network has activated an unprecedented protocol. Now, that's strange, isn't it? A planetary defense system designed to protect Earth, mobilized against an object that poses no threat at all. You see, sometimes science doesn't move because it has the answers, it moves because something doesn't fit. A pattern that shouldn't exist, a signal that whispers, "Look again." And on that night, when astronomers around the world turned their eyes toward the returning light of a forgotten visitor, the universe seemed to pause. What was it about this interstellar traveler, 3i Atlas, that stirred such urgency? Why did an entire global network come alive before anyone even knew what they were looking at? Perhaps, in that moment, we were not defending our planet, but our curiosity. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So let's continue. Well, you see, before we can understand why the world reacted the way it did to 3i Atlas, we need to go back. Not too far, just far enough to remember the moment humanity decided to build a shield not of steel or missiles, but of vigilance. It was the early 21st century, and the truth was dawning on us that space, beautiful and vast as it is also restless. Tiny fragments of rock drifted through the void, each one a silent reminder of our planet's fragility. We had only to look at the craters of the moon to know what could happen if one of them found its way to us. That realization gave birth to the International Asteroid Warning Network, IAWN. A name that sounds bureaucratic perhaps, but behind it was something profoundly human: cooperation. The United Nations endorsed it in 2014, calling on scientists, observatories, and agencies around the world to form a global early warning system for cosmic hazards. It wasn't glamorous work, no, but it was essential, because for the first time, we were acknowledging that our survival depended not on borders or flags, but on our ability to look outward, together. Imagine it: hundreds of telescopes scattered across continents, all watching the same dark sky. Data flowing like rivers between institutions, crossing time zones, languages, and political divides. The aim was clear: detect, track, and assess any near-Earth object that might threaten us. The logic was simple enough: if you can see it coming, you have a chance to act. But the deeper truth was almost poetic. The very act of watching made us safer. Awareness itself became a form of defense. For more than a decade, IAWN operated quietly, like a heartbeat beneath the noise of everyday astronomy. It catalogued thousands of asteroids, refined orbital paths, issued routine bulletins that barely made the news. Most of its alerts were technical, dry, the kind of documents only astrophysicists truly read. And that's the thing: nothing about IAWN was ever dramatic. It wasn't meant to be. It was a guardian designed for silence, an instrument tuned to the absence of catastrophe. And then, somewhere along the way, something began to shift. The discovery of the first interstellar object, Oumuamua, in 2017, changed everything. It was like catching a whisper from another solar system, a fragment of someone else's story passing through ours. Oumuamua's shape, its tumbling motion, its odd acceleration, they defied our expectations. 2 years later came Borisov, a more conventional visitor, a comet whose chemistry told us it had formed around another star. Each of these objects reminded us that the universe is not closed. We are part of a larger ocean, and sometimes its tides reach us. Yet despite the fascination they inspired, neither Oumuamua nor Borisov ever triggered a planetary defense response. They were observed, studied, discussed, yes, but IAWN remained silent. After all, neither posed a threat. They were curiosities, not crises. And that's what makes the activation in 2025 so intriguing. Why now? Why this object? Well, perhaps we can imagine the atmosphere within the network before that moment. In the quiet corridors of observatories, in data centers and control rooms, the sense of purpose that had lain dormant for years was about to stir. The people who worked for IAWN astronomers, engineers, analysts, had trained for impact scenarios, for asteroid threats. Their drills and simulations often ended in numbers, probabilities, trajectories, mitigation plans. But when the word interstellar appeared on their screens, something more primal must have flickered inside them. Curiosity wrapped in unease. IAWN was not just a network, it was a choreography of institutions. NASA's Planetary Defense Coordination Office in the United States, the European Space Agency's Near-Earth Object Coordination Center in Italy, Japan's JAXA, and observatories from Chile to South Africa, all connected by shared protocols and encrypted channels. Every detection was logged, verified, and passed through layers of analysis. The network's strength lay not in a single telescope, but in synchronization, a planetary mind watching the heavens. And yet, for all its precision, the network's decisions were never purely mechanical. Human judgment still sat at the center. Someone, somewhere, had to decide when to move from observation to action, when to call a drill, when to activate. The protocol for that decision was meant to be unambiguous threat detection based on orbit prediction and impact probability. But what if something didn't fit into those boxes? What if the object wasn't dangerous in the usual sense, but strange in another? You see, science, for all its equations, is still a story told by people. And when a story feels wrong, when the pieces refuse to align, curiosity becomes a form of urgency. The activation of IAWN in response to 3I Atlas may have been, at least in part, an act of instinct. The data said one thing, the intuition of the scientists said another. And intuition, in science, is often where discovery begins. The idea of a planetary defense system sounds almost cinematic, doesn't it? But in reality, it's built on spreadsheets, observation logs, and a culture of quiet discipline. IAWN's first mission was to coordinate to ensure that when an object appeared, everyone looked at it in the same way. There was a beauty in that structure, in the way global coordination became a mirror of cosmic order. Each telescope, a note in a grand symphony of vigilance. Over the years, the network developed its own rituals, scheduled conferences, data sharing protocols, training exercises, labeled capability assessments. These were simulations, of course, but they carried a sense of gravity. Behind every exercise lay the awareness that one day it might not be a drill. The line between preparation and reality was thin, and no one knew when it might blur. And then, as the years passed without major incident, complacency began to settle in. Some questioned the need for continued funding. Others argued that automation could replace coordination. The world's attention drifted elsewhere to pandemics, politics, the usual tides of human distraction, but the watchers, the quiet ones, stayed at their posts. Because that's what science does, it waits, patiently. When 3I Atlas entered the picture, the machinery of that patience suddenly came alive. It was as if the network had been holding its breath for a decade, and now, finally, it exhaled. The activation wasn't just a technical event, it was emotional. For those inside the system, it was the culmination of everything they'd built, a chance to prove that global vigilance could work. For others, outside the circle, it was confusing. Why mobilize an entire network for a visitor that posed no threat? Maybe the answer lies not in the data, but in the mindset. Because you see, The scientists within IAWN had spent years looking for danger, and when you spend long enough searching for danger, you begin to recognize patterns others overlook. They must have sensed something in the early readings, something subtle, almost imperceptible. An anomaly in the light curve, a fluctuation in orbital velocity, or perhaps just a feeling that this object was not like the others. And that's where the paradox began, a planetary defense network acting not in response to threat, but to curiosity. It's almost poetic, isn't it? A system built to guard against destruction suddenly mobilized to understand creation. The lines between protection and exploration blurred, and in that blur, the story of 3I Atlas began. Looking back, the activation on that October night in 2025 might seem disproportionate, but when seen through the eyes of those who built the network, it made perfect sense. For years, they had prepared for the unimaginable. And when something truly unimaginable appeared not as a threat, but as a mystery, how could they not respond? IAWN's history is in many ways the story of how humanity learned to listen to the cosmos with purpose. From fear of impact, it evolved into a culture of attention, of readiness. It taught us that looking up is not just an act of curiosity, but of responsibility. Because every observation, every data point is a thread in the fragile fabric that connects us to the wider universe. And so, when the signal came, when the object known as 3I Atlas re-emerged from behind the sun and the instruments lit up with its signature, the network moved as one. Telescopes aligned, observatories synced, and the world's most powerful eyes turned toward a single, distant speck of light. A speck that, somehow, had stirred the machinery of an entire planet. But the real question wasn't how they reacted, it was why. What did they know before the world did? What had they seen in the data that made them act not out of fear, but anticipation? Perhaps, as we move deeper into this story, we'll begin to see what they saw and understand why, for the first time in history, humanity's gaze turned not inward for safety, but outward for answers. And that's where our journey continues. And so, as the world's instruments locked, their gaze upon that distant speck of light, a deeper question began to rise. What exactly was it that we were looking at? You see, the very term interstellar object carries with it a quiet sort of awe. It means something not born of our sun, not tethered to our familiar system of planets, comets, and asteroids. It means a traveler from elsewhere, a wanderer whose story began around another star, perhaps hundreds or thousands of light years away. And somehow, by chance or by cosmic design, it had found its way here. To understand why 3I Atlas mattered so much, we need to remember its predecessors, those earlier visitors that had slipped silently through our solar neighborhood. The first, of course, was Oumuamua, discovered in October 2017 by the Pan-STARRS telescope in Hawaii. The name itself, from Hawaiian, means scout or messenger from afar. Fitting, isn't it? Because that's what it was, a messenger. When astronomers first plotted its path, they realized almost immediately that it was unlike anything they had seen before. Its orbit wasn't elliptical, the kind you'd expect from an asteroid or a comet born under the sun's gravity. It was hyperbolic, an open curve that meant it came from outside and would never return. At first, it was thought to be an asteroid, a simple rock wandering through space. But its brightness changed in ways that didn't quite fit. It tumbled, elongated, like a shard of metal or a fragment of something once larger. And then there was that subtle, inexplicable acceleration, as if it were being pushed by something other than gravity. Some called it outgassing, the release of vapor from its surface, but there was no sign of the typical cometary tail. Others, more daring, suggested perhaps it was artificial, a piece of alien technology. But science, cautious and disciplined, doesn't rush toward the extraordinary. Still, the idea lingered, the whisper that perhaps this was more than just a rock. 2 years later, in August 2019, came the second visitor, Borisov. Unlike Oumuamua, Borisov looked and behaved like a comet. It had a tail, it released gases, it glowed. Its chemical makeup showed traces of cyanide and carbon monoxide, familiar ingredients, yet in proportions that hinted at an origin around another star. For the first time, we could study the material of another solar system directly. The instruments captured spectra, the fingerprints of its composition, and what they revealed was both comforting and unsettling. Comforting, because it confirmed that the building blocks of life were not unique to us. Unsettling, because it reminded us just how many worlds might exist out there, each with their own stories. And yet, neither of these visitors, wondrous as they were, ever stirred the machinery of the International Asteroid Warning Network. The network observed, certainly, but it did not activate. There was no protocol, no coordinated campaign, no sense of alarm. These objects were strange, yes, but not dangerous. They came, they passed, they vanished into the dark. Life on Earth continued, unchanged. That's what makes 3I Atlas so different. When it appeared in the records, faint, blurred, just a hint of motion against the background stars, the reaction was instant, coordinated, almost rehearsed. To understand that reaction, we have to grasp what makes an interstellar object so profoundly captivating to the human mind. Because, well, when something crosses the vast distances between stars, it carries with it a kind of story. Every atom within it has been exposed to cosmic radiation for billions of years. Its surface holds the memory of alien suns. It's not merely a piece of debris, it's a message written in chemistry and motion. When we call something interstellar, we are, in a sense, calling it a survivor. These objects are ancient remnants of worlds long gone, ejected during the chaotic youth of their home systems. Perhaps they were once part of planets that shattered in collisions, or moons cast adrift by gravitational tides. They wander through the interstellar medium, through clouds of dust and hydrogen, enduring temperatures close to absolute zero, for millions upon millions of years. Each one is a time capsule, a frozen echo of a star's distant past. So, when 3I Atlas entered our sky, the excitement was natural, but excitement alone doesn't explain activation. No, something else must have been there, some peculiarity in the data, some small anomaly that whispered, "This one is different." Maybe it was its velocity, faster than expected for an ordinary comet. Maybe it was its reflectivity, its light scattering in ways that didn't fit our models. Or maybe it was the simple fact that its trajectory, precise and unwavering, seemed almost deliberate. You know, there's something humbling about realizing that interstellar space isn't empty. It's not a void, but a sea filled with silent travelers drifting between the stars. For centuries, we looked outward and thought of the distances as barriers, as impossible divides. But now, objects like these are reminders that the cosmos is connected in ways we're only beginning to understand. The dust that forms our world, the carbon in our bodies, the oxygen we breathe, all were once parts of other stars. The interstellar visitors are, in a way, our distant relatives returning home. And that raises another thought. If these fragments of other systems can find us, then perhaps we, too, are sending out fragments of our own. Space is littered with the debris of human curiosity, old probes, fragments of rockets, signals that stretch endlessly into the void. Somewhere, perhaps, another civilization looks up at their sky and wonders about a faint, metallic object passing by, just as we wonder about 3I Atlas. But what's truly fascinating is how differently we respond when the unknown comes close. In the case of Oumuamua and Borisov, we were observers, detached, analytical. We studied them as curiosities, kept them at arm's length. But by 2025, something had changed in our collective psyche. Perhaps it was the growing awareness of our fragility, the way the pandemic years and climate crises had reminded us that we are not as in control as we once believed. Perhaps it was technological, our instruments had grown more sensitive, our networks more integrated. Or perhaps, and this is the more unsettling possibility, we had simply become more aware that the universe was not indifferent. The scientists who detected 3I Atlas described it as faint, small, moving fast. But even the faintest light can set off waves of speculation. In the first few days after its discovery, its orbit was uncertain. Some models placed it within reach of the Sun's gravity, others showed it escaping almost immediately. Its eccentricity, a measure of how open its path was, turned out to be greater than 1, confirming its interstellar nature. It was traveling at more than 200,000 kilometers per hour, a speed that meant it came from far beyond the gravitational influence of any nearby star. That speed alone makes such objects difficult to study. They pass through our neighborhood in a matter of weeks or months, giving us only a narrow window to observe. But it also raises an extraordinary question. If these travelers are so rare and fleeting, how many others have passed unseen? How many have slipped through, their stories untold? The answer, most likely, is many. Our instruments are limited by perspective, by timing, by the thin veil of sunlight that hides so much of the sky. When the International Asteroid Warning Network began to analyze the data from 3I Atlas, the first thing they would have done is rule out local origins to make certain it wasn't an asteroid deflected by Jupiter or a comet from the far edges of the Oort cloud. Only after verifying its hyperbolic path would the term interstellar appear in the logs. But that word changes everything. It transforms the object from a routine observation into something cosmic, something worthy of every telescope we can muster. It's remarkable how, with each interstellar visitor, our imagination stretches further. With Oumuamua, we wondered if it was a probe. With Borisov, we imagined other solar systems forming planets like ours. And now, with 3I Atlas, we seem to be confronting a different kind of mystery, not just about what it is, but why it came when it did. Could it be coincidence? Or could the timing itself hold meaning, a pattern we haven't yet deciphered? The truth, of course, is that the universe doesn't send us messages, or if it does, it writes them in a language of probability and light. But as humans, we can't help but search for meaning. We are pattern-seeking creatures, forever trying to find stories in the noise. That's what science is, in the end, the disciplined search for pattern in chaos. So here we are, at the threshold of understanding. We've seen 2 such travelers before, but never one that set in motion the machinery of planetary defense. Never one that made humanity act as if the unknown itself were a call to arms. It's almost as if, deep down, we sensed that this visitor carried something more than dust and ice, that it carried questions we weren't ready to ask. And perhaps that's why, when 3I Atlas emerged from behind the sun newly visible, newly free from the blinding glare, the reaction was not calm analysis, but readiness. Because sometimes, what we see in the night sky is not just an object moving through space. Sometimes, it's the reflection of our own unease, our own yearning to understand the unfamiliar. As telescopes around the world began to focus, and data streamed through the channels of IAWN, the first images of 3I Atlas began to appear, a faint, elongated smudge against the darkness. Astronomers studied its motion, its brightness, its spectral fingerprints, and something curious began to emerge. The light it reflected did not behave quite as expected. There was structure in its glow, subtle variations that hinted at complexity. And that's when the questions began to multiply. What exactly were they looking at? What was this visitor made of? And most of all, what was it doing there, moving just so, at that particular moment in time? Those questions would soon lead the scientific world into the next phase of inquiry, the moment when 3I Atlas would reveal its first true signature, not through its orbit, but through its light. And that, well, is where the mystery deepens. When the light of 3I Atlas finally emerged from behind the sun, it was as though the universe had taken a breath and then exhaled into the waiting eyes of our machines. For months, The object had been hidden in what astronomers call solar conjunction, that strange interval when a celestial body passes behind the Sun as seen from Earth. During that time, it is invisible, swallowed by the brilliance of our star. To most of us, that would seem like nothing more than a brief interruption in observation. But for those who had been following 3I Atlas, it was an agonizing silence. Because when something vanishes into the glare of the Sun, you can't just look away, you wait. And in that waiting, there's always the possibility that it might not come back. You see, solar conjunctions are like moments of blindness. Every year, planets, asteroids, even spacecraft pass behind the Sun's brilliance, and we lose sight of them for a while. We trust our mathematics to tell us where they are, what path they follow, and when they'll return to view. But mathematics, precise as it is, doesn't quiet the unease of not seeing. Especially not when the thing you're waiting for comes from another star. When 3I Atlas disappeared into conjunction, sometime around mid-year, the world's telescopes paused their tracking. The data streams slowed. The predictions were made, the coordinates plotted, and the watchers waited. And yet, something curious happened in that stillness. Even as the object was hidden, the International Asteroid Warning Network began preparing. There were encrypted notices, pre-coordinated schedules, observation drills that resembled rehearsals more than research. It was as if they were anticipating its return not with curiosity, but with intent. And that's strange, isn't it? Because normally, such preparation follows a confirmed detection, not precedes it. In the quiet corridors of data centers and observatories, the questions must have begun to circulate. How did they know to ready the network? What made them act as though the reappearance of 3I Atlas was not just expected, but crucial? Perhaps someone had seen something in the early data before it slipped. Behind the Sunday, a flicker in its trajectory, a subtle deviation in light signature, something so small it would mean nothing to the untrained eye. Or perhaps, and this is more poetic, they sensed that the moment the object came out of the Sun's shadow, something about it would change. When the glare finally subsided and the object returned to visibility, the first images arrived almost instantly. They came from observatories scattered across the globe, from Hawaii, Chile, the Canary Islands, the deserts of Australia. Each one captured the same faint, bluish streak, moving with deliberate precision across the night sky. But here's where the story takes an unexpected turn. The timing of IAWN's activation wasn't reactive. It coincided almost perfectly with the first moment 3I Atlas emerged from conjunction, as though the campaign had been planned down to the minute. The network's instruments were already calibrated, the observation windows already synchronized. That kind of readiness doesn't happen by coincidence. It's orchestrated. It's as if the world had been waiting not for the object to return, but for permission to begin. Now, to understand why that's so peculiar, we need to talk about what solar conjunction really means for observation. When a celestial object passes behind the Sun, it enters a region where light and radiation distort its visibility. Ground-based telescopes can't see through that glare, and even space telescopes have to turn away to protect their instruments. It's like trying to listen to a whisper while standing beside a jet engine. For that period, days, weeks, sometimes months, the object effectively disappears. Any changes it undergoes during that time are hidden from us. So, when 3I Atlas emerged, every eye turned toward it, waiting to see if it looked the same. But what the instruments found was unsettling. Its brightness had shifted, subtly but unmistakably. The reflected light seemed to vary, suggesting either a change in its surface composition or something even more intriguing activity. Some astronomers described it as a thin veil of vapor, a halo faintly visible around its core. Others insisted it was a data artifact, a product of imaging error. But as more observations poured in, the pattern persisted. The object wasn't the same as before. In the days that followed, IAWN launched what they termed an interstellar observational exercise. though the scale and coordination of it far exceeded anything that could reasonably be called a drill. Telescopes that normally competed for observation time were suddenly united under one directive. Space agencies adjusted satellite schedules, even redirected assets meant for deep space research. Hubble, the James Webb Space Telescope, the Very Large Telescope, Mars Express, all of them aligned, pointing toward a single point in space. The cost of such coordination was enormous. The intention behind it, still unclear. But perhaps it wasn't about the cost. Perhaps it was about what they feared they might see. You see, in the history of astronomy, we've grown used to predictable behavior. Comets brighten as they near the Sunday, asteroids remain inert. The universe follows patterns, and we take comfort in those patterns. But 3I Atlas seemed to violate expectation. Its brightness didn't follow the normal curve of a cometary body. Its tail, if that's what it was, appeared to shift direction slightly, as if responding not only to sunlight, but to something else. And the velocity. Oh, that velocity. It was too precise, too consistent, almost like an object being steered by laws we hadn't accounted for. There's a strange duality in astronomy. The closer we look, the more mysterious things become. When Oumuamua was discovered, we thought it might be a rock. Later, we thought it was a fragment of ice. Later still, a sliver of something we couldn't quite name. And now, with 3I Atlas, that same unease was returning. The data didn't match the models. The models didn't match the intuition. And intuition, though not always scientific, has a way of unsettling certainty. Imagine the tension in those early hours, the mission logs filling with numbers, magnitudes, coordinates, as astronomers tried to make sense of what they were seeing. Each new set of readings only deepened the enigma. Some saw traces of carbon dioxide emission far higher than any known comet. Others noted a lack of typical dust signatures, as though the surface were smooth, metallic even. And yet, there it was, moving exactly as it should through the gravitational fabric of the solar system, on a path that would soon take it away forever. And so, the question began to echo, through observatories and control rooms. What had happened to 3I Atlas while it was hidden behind the sun? That's the thing about the cosmos. Its light is slow, its stories delayed. By the time we observe an event, it has already passed. So whatever had changed, whatever had awakened in that blinding interval, was already history by the time we saw it. Some suggested a simple explanation, that the heat of the sun had vaporized a layer of volatile material, exposing new compounds beneath. Others suspected structural breakup, the fragmentation of an ancient body finally succumbing to thermal stress. But even those hypotheses didn't fully account for the data. The symmetry, the consistency of the emissions, the narrow confinement of its spectral lines, they hinted at something almost controlled, and perhaps that's why the network acted as it did. Perhaps the activation was not driven by fear of impact, but by the quiet realization that this might be our only chance to witness something unprecedented, an interstellar object undergoing transformation under our star's light. For a moment, just imagine what that must have felt like for the people watching, to see, in the stillness of night, the reflection of something that had traveled billions of years across space, now altered, now luminous in a way no one could explain. It must have felt like looking at a secret, half revealed. And yet, beneath the scientific wonder, there was something else, a hum of unease. Because in the language of the network, in the memos exchanged during that period, certain phrases appeared that hadn't been used before. Pre-coordinated observation protocol, non-impact contingency, data embargo pending review. Bureaucratic words, yes, but behind them you can sense the weight of uncertainty. It was as though the line between discovery and alert had blurred. Was this an astronomical campaign or something closer to a classified operation? The instruments were the same, the telescopes familiar, but the tone had changed. The data was being handled differently, access was restricted, and in the world of open science, That kind of secrecy always draws attention. But perhaps secrecy wasn't the goal. Perhaps caution was. Because if 3I Atlas truly behaved unlike anything before it, then every fragment of information had to be verified. Every observation double-checked, every model recalculated. The risk wasn't danger, it was error, misinterpretation, the fear of announcing something that might later prove false. Still, the sense of anticipation grew. Night after night, new data poured in, and the object's light curve began to tell a story, one that didn't match any known comet or asteroid. There was coherence in its motion, an almost mechanical steadiness. The vapor emissions, if that's what they were, fluctuated in intervals too regular to be random. And somewhere in that data, hidden between the lines of numbers, was the first suggestion that 3I Atlas might not be entirely natural. But that, of course, was just speculation, the kind of thought whispered over coffee at midnight, when the screens glow faintly and the stars outside seem to listen. Still, speculation has a way of guiding curiosity, of pushing observation further than protocol allows. And as the object continued to drift outward, its brightness waxing and waning in defiance of expectation, the question could no longer be avoided. What exactly was 3I Atlas? The world would soon demand answers. And the scientists, bound by data, but driven by wonder, would begin to dig deeper into its trajectory, its chemistry, and the very light it reflected. Because somewhere within that light lay the first clues to its true nature. And as they would soon discover, those clues pointed towards something even stranger than anyone had imagined. The activation of the campaign spread through the astronomical community like a ripple across still water. One moment, the screens were quiet lines of data ticking by in the usual rhythm of cosmic observation, and the next, a series of encrypted transmissions began to appear. They were marked with a phrase few had ever seen before: International Interstellar Observation Protocol. In less than 12 hours, observatories on 5 continents had received their instructions. By morning, what had begun as an isolated anomaly had become the largest coordinated astronomical campaign in human history. It wasn't a press event. There were no announcements, no speeches. Instead, there were forms, registration sheets, technical agreements, digital signatures, authorizing participation. Each observatory that wished to join the campaign had to submit proof of compliance with IAWN standards: timing, precision, calibration verification, data encryption, and telemetry synchronization. It was, in every sense, a military operation. Only the battlefield was the night sky. Observers were astonished by the formality of it all. Even veteran astronomers, who had spent decades working with the Planetary Defense Network, had never seen such rigor. Normally, observation campaigns were collegial, almost improvised, a shared enthusiasm that transcended institutions. But this felt different. It was as if the sky had suddenly been placed under command. Well, you see, when humanity organizes itself on a planetary scale, it reveals both its brilliance and its fear. The brilliance lies in coordination, hundreds of instruments across the Earth and in orbit, all focusing on one object at the same time with atomic-level precision. The fear lies in the language, the quiet implication that this was not just observation, but readiness. The documents called it an exercise capability, a phrase more often found in defense strategy than scientific study. Behind those words was a simple truth: no one quite knew what they were dealing with. The campaign began formally at midnight on the 21st of October, 2025. The first phase was called acquisition. During this window, each participating telescope was to acquire lock-on 3I Atlas and report its coordinates to the central server in near real time. The goal was to triangulate, to confirm the trajectory to within fractions of an arc-second. The instructions read like choreography, a cosmic ballet of timing and trust. For the space-based instruments, things were even more complex. The Hubble Space Telescope was tasked with capturing high-resolution images in visible light. The James Webb Space Telescope, operating nearly 1 million miles from Earth, would scan in the infrared, analyzing heat signatures that could reveal the composition of surface materials. The Very Large Telescope in Chile provided spectral readings from the ground, while the European Space Agency's Mars Express orbiter was retasked to capture secondary imaging from a different angle, providing a rare cross-solar perspective. The coordination between these instruments required precise timing, as even a delay of a few seconds could render the data useless. Imagine the logistics. Each observatory had its own operating schedule, its own priorities, and yet, for those few nights, they all served one master. The cost of aligning such resources, the manpower, the power usage, the lost observation time reached into the millions. And still, no one outside the network seemed to question it. Perhaps because the world had other concerns, or perhaps because the campaign was designed to be quiet, the data, after all, wasn't open. It was proprietary to the IAWN participants, embargoed until analysis was complete. Inside those circles, though, the atmosphere must have been electric. The scientists called in from every corner of the globe joined virtual briefings that spanned time zones. There were daily updates, mandatory seminars, even specialized subgroups formed to interpret specific data streams: photometric, spectrographic, dynamical. The sense of secrecy was palpable, not in the paranoid sense, but in the sacred one, the way explorers might whisper before opening an ancient door. Perhaps the strangest thing of all was the language used to describe the campaign. One internal memo, leaked weeks later, referred to it not as an observation but as a containment rehearsal. Another used the phrase non-impact contingency coordination. Those terms, on their own, mean little bureaucratic phrasing, perhaps. But in the context of 3 IATLAs, they stirred unease. What, exactly, was being rehearsed? The schedule itself was punishing. Observers worked in shifts, tracking the object as it passed through the constellations Aquarius and Capricornus, measuring every flicker in its light curve. When one hemisphere turned toward daylight, the other took over, ensuring continuous surveillance. For days, there were no gaps in the data stream. Even the Deep Space Network joined in, its massive antennae in California, Spain, and Australia listening for radio reflections, as if expecting the object to whisper back. And that's the thing, when you mobilize so much attention, you begin to sense intent in the very act of watching. The scientists began to notice how the campaign mirrored the architecture of a defense drill. There were command channels, coded identifiers, pre-approved communication windows. Even the phrasing of instructions, stand by for confirmation, maintain acquisition lock, verify visual persistence, echoed military cadence. It was as if the universe had become a theater, and humanity, without quite realizing it, had adopted the language of readiness. But readiness for what? Perhaps it was nothing more than the institutional reflex of caution, the natural instinct of those who spend their lives guarding against cosmic hazards. Or perhaps there was something in the data, something the leadership of IAWN had seen and not yet revealed. Because the level of coordination was not proportional to any known risk. The object was moving away, not toward us. Its path was harmless, and yet the response was absolute. Some of the scientists involved began to joke, half nervously, that they were part of the quietest emergency in history. They were told not to discuss their findings until the final review. The press inquiries that inevitably followed were met with polished responses, routine coordination exercise, standard observation protocol. But no one could remember any routine exercise that had ever involved the world's most advanced telescopes operating in tandem. If you think about it, there's something deeply human in that paradox, our habit of masking wonder with procedure, of hiding awe behind acronyms. We fear the unknown, so we surround it with paperwork. We write protocols for it, as though bureaucracy could make mystery safer. Still, in those first nights of observation, there must have been moments when the scientists forgot the rules. When the images arrived from Hubble, when the first spectral lines appeared on their screens, they would have seen something extraordinary: the faint green glow of carbon dioxide emission, the peculiar absence of water vapor, the steady pulse of reflected light that seemed almost rhythmic. It was unlike any comet or asteroid in the databases. The data hinted at complexity, perhaps even structure, and as the numbers filled their monitors, the tone of the campaign began to shift. What had started as an exercise was becoming something else, a search. A search not for threat, but for understanding. One researcher later described it as the moment when the data started to breathe. That's how it feels, sometimes, in science, when you look at a set of readings and realize they're not random, that there's a pattern beneath the noise. It's like listening to static and hearing the faint rhythm of a heartbeat. But this heartbeat was interstellar. The deeper the analysis went, the more questions emerged. Why was the object emitting carbon dioxide at such an extraordinary ratio? Why did its apparent magnitude fluctuate in near-regular intervals? And why, above all, had the network been prepared for this, almost as if it had been waiting for it? No one said it aloud, but everyone thought it. This wasn't just a campaign. It was an audition, a test of whether humanity could act as one in the face of the unknown. The IAWN had become a rehearsal not for war, but for awakening. And yet, beneath the harmony of coordination, there were murmurs. Some data packets were delayed. Certain observatories were told to reroute their findings through encrypted channels rather than the shared network. A few researchers, noticing inconsistencies in their datasets, requested clarification and received none. It wasn't suspicion, exactly. It was silence, the kind that makes you wonder what's not being said. Still, the campaign continued, driven by the momentum of its own purpose. Each night, the light from 3I Atlas arrived, photon by photon, carrying secrets from across the void. The telescopes captured them, decoded them, and sent them back to Earth, the universe, whispering to itself through the machinery of human curiosity. And as the data accumulated, one question began to rise above all others. If this was merely a training exercise, why did it feel like a search for contact? Perhaps that's what made the campaign so haunting, that subtle collision between procedure and wonder. Because even within the rigid structure of observation windows and technical briefings, the scientists could feel it, that sense of something watching back. And as the campaign moved into its next phase, shifting from coordination to measurement, that feeling only deepened. The precision now demanded of them went beyond standard astronomy. They were no longer just recording light. They were tracing motion, mapping the delicate dance of a body moving through the gravitational currents of the Sunday. It required an ancient art, the oldest in the language of the stars, astrometry, the science of measuring the heavens. And so, the campaign's focus began to narrow, from the global to the precise, from the collective to the individual, from the spectacle of coordination to the quiet discipline of position and motion, because somewhere, within the numbers, within the drifting coordinates of 3I Atlas, there was a story waiting to be told. A story of trajectory, of intent, perhaps even of origin. And as the observers turned from the grand theatre of cooperation to the intimate art of measurement, they would soon discover that precision can reveal truths that awe alone cannot. Astrometry, you see, is one of those quiet sciences, delicate, precise, almost meditative. It's the art of knowing where something is and how it moves, with a precision that borders on reverence. Long before humanity could send probes to the outer planets, before we even understood the scale of our own galaxy, there were astronomers drawing lines between stars, measuring angles so small they could barely be imagined. To them, the universe was a vast geometry, and every point of light was a coordinate in an invisible dance. And now, In the autumn nights of 2025, that same ancient craft was being called upon once again, not for a planet, not for a moon, but for a traveler from another star. The campaign that had begun as a global exercise was now entering its most demanding stage, mapping the true motion of 3I Atlas. To the untrained eye, the task might seem trivial. Point a telescope, take a picture, measure the object's position, but in reality, it is a symphony of complexity. The object moves swiftly, the Earth rotates, the atmosphere wavers, instruments shift by microns under temperature changes. To measure the position of an object moving at over 200,000 kilometers per hour, and to do so within a margin of a few milliarcseconds, requires not only precision, but patience. Every image had to be aligned to reference stars, every frame corrected for parallax, every photon accounted for as if it were a word in a cosmic sentence. And the irony, of course, was that 3I Atlas was barely visible. Even through the most powerful lenses, it appeared as nothing more than a faint smear against the tapestry of stars. Its light was distorted by its coma, that thin halo of vapor that surrounded it, scattering photons in unpredictable ways. Measuring such a thing was like trying to fix a ruler against a candle flame. It flickered, it wavered, and yet within that instability lay meaning. One of the senior analysts at the European Southern Observatory described the process as chasing a shadow across water. The object's image would shift slightly with each observation, sometimes appearing larger, sometimes brighter, as though the light itself were breathing. But through careful cross-referencing, the team began to extract a pattern. The orbit was confirmed as hyperbolic, not bound to the Sunday. Its path would take it out of the solar system entirely, never to return. But there was something else, something more subtle, hidden in the residuals, the minute differences between prediction and observation. Those residuals didn't behave as expected. They weren't random. They formed a faint but consistent bias, a deviation that suggested a small, continuous acceleration, not unlike what had been seen with Oumuamua years earlier. At first, the analysts dismissed it as instrumental error, then as optical interference, then as solar radiation pressure, the gentle push of sunlight itself. But as the data improved, those explanations began to weaken. The acceleration was too steady, too coherent. It seemed, impossibly, to be under control. Now, in the language of science, control is a dangerous word. It implies intent. And scientists, well, they are cautious with such ideas. But as more data arrived, it became clear that 3I Atlas wasn't simply being carried by gravity alone. Something was guiding its drift. Perhaps it was gas venting from within, a jet of sublimating carbon dioxide creating thrust. Perhaps it was the shape of the object, a natural sail catching sunlight in just the right way. Or perhaps, though few dared say it aloud, it was something else entirely, something that behaved like propulsion. But astrometry is not about speculation. It's about numbers, and the numbers were clear. The object's position, when plotted against time, did not align perfectly with Newtonian predictions. And when the data was shared between observatories, even the smallest discrepancies, a fraction of a second in timing, a tiny variance in angular position reinforced the anomaly. That's the beauty of this science, really. It's not just measurement, it's humility made visible. Because every observation, every point on a graph, carries with it the reminder that our understanding is still incomplete. The universe never moves exactly as we expect it to. The teams around the world began refining their methods. They used reference catalogues from the Gaia mission, which had mapped the positions of over 1 billion stars with exquisite precision. They corrected for atmospheric distortion using adaptive optics. They synchronized atomic clocks across continents so that every exposure could be stitched together into a seamless timeline of motion. The goal was not simply to know where 3I Atlas was, but to understand how it behaved, whether it rotated, whether its brightness fluctuated with a rhythm, whether its acceleration hinted at internal processes. And slowly, a picture began to emerge. The object was tumbling, but not randomly. Its rotation appeared to have a slow periodicity, around 8 hours, perhaps more. Its surface reflectivity was uneven, suggesting contrasting materials, some dark, some highly reflective. The light curve, when charted, pulsed with an odd regularity, like a heartbeat too, steady for chaos. At times, it almost felt alive. One can imagine the scientists watching their data streams late into the night, the faint blue glow of computer screens flickering against tired eyes. The numbers, the graphs, the residuals, all whispering that something didn't quite fit. And when things don't fit in science, that's where discovery hides. The parallels with the DART mission from a few years earlier became clear to many of them. That was the first time humanity had deliberately altered the motion of a celestial body, a small asteroid named Dimorphos, by crashing a spacecraft into it. It was a test of planetary defense, proof that we could, in principle, nudge a rock in space. The precision required for that mission was extraordinary, measuring changes of a few centimeters per second across millions of kilometers. And yet, what they were seeing now in 3I Atlas made DART seem almost simple. Because this time, there was no impact, no control, no deliberate intervention. Whatever was moving the object, it was doing so naturally or unnaturally on its own. And so, the study of its motion became a philosophical exercise as much as a technical one. What does it mean for something to move naturally in the universe? We assume that all motion arises from force, from gravity, from radiation, from thermodynamics. But what if, somewhere between those laws, there is a kind of agency we don't yet understand? Perhaps not intelligence as we define it, but a property of matter, ancient and subtle, a way for the universe to shape its own trajectories. It's easy to get lost in that kind of thinking when you're staring at the numbers, when you realize that the deviation, that faint signature in the data, might be telling a story billions of years old. In one of the internal reports circulated among the network, a single sentence stood out. Astrometry defines not where we are, but how we move through uncertainty. It was a poetic statement, rare in technical documentation, and yet it captured the mood perfectly. The act of measurement had become an act of reflection, both scientific and human. You see, measuring the heavens has always been a mirror of our own condition. We measure because we seek certainty, and yet every measurement reminds us that certainty is fleeting. The stars move, the light bends, even the space between them stretches with time. The universe is not fixed, it's fluid. And so, by tracking something as elusive as 3I Atlas, we were, in a sense, tracking our own ability to comprehend impermanence. Still, the data kept coming, and with each refinement, the mystery deepened. The object's trajectory was confirmed to be hyperbolic, yes, but its exact shape that was harder to pin down. Some readings suggested it was elongated, spindle-like. Others hinted at a flattened geometry, perhaps a disk. The variations in brightness made it impossible to tell. And then came another surprise. The spectra, when compared with known cometry data, revealed a dominant signature of carbon dioxide, far higher than expected, and an absence of certain elements, like water vapor and silicates, that should have been there. This wasn't just unusual, it was unprecedented. Something about the chemistry of 3I Atlas didn't belong to the kind of objects we know. It was as if we were measuring the motion of something ancient, but not entirely natural. By now, even the most skeptical voices had grown quiet. The numbers spoke for themselves. The deviations were real. The chemistry was strange. The light curve whispered secrets no one could interpret. And so, the campaign entered a new stage, not just to track, but to probe. The spectrographs were recalibrated, the exposure times lengthened, and the focus turned from position to composition. Because once you know how something moves, the next question is what it's made of. And that, perhaps, is the deeper meaning of astrometry. It teaches us that movement is not just mechanics, it's expression. The path an object takes reveals something of its inner nature, just as the choices we make trace the contours of who we are. Somewhere in those endless rows of data, in the shimmering points of starlight compared and subtracted, the observers must have felt it, that quiet awe that comes when science brushes against mystery. Because they were no longer just watching a comet. They were watching a story unfold, written in coordinates and velocity, told across the black sea of space. And as the instruments turned once more toward that wandering light, the next layer of the mystery began to unfold. The chemistry, the breath of its surface, the strange and almost deliberate signature in its spectral glow. That, of course, would take them even deeper into the realm where physics and wonder meet. Into the question of what, exactly, 3I Atlas was made of. Once the nascent astrometric data had been refined and the trajectory confirmed beyond doubt, attention turned to what the numbers could tell us about the nature of the object itself. For months, 3I Atlas had been little more than a point of light, an interstellar whisper. But through the careful accumulation of data, brightness, spectral analysis, and motion, a picture was beginning to form. And that picture was unlike anything the solar system had seen before. The object, according to preliminary models, measured somewhere between 440 meters and 5.5 kilometers in length. That range alone was staggering. Even our best telescopes struggled to resolve an object so distant and fast. It moved through the void at roughly 210,000 kilometers per hour, swift enough to cross the distance between Earth and the Moon in less than 2 hours. At that speed, it was not simply moving through the solar system. It was slicing through it, untouched by gravity's grasp, on a path that would take it back into interstellar space forever. To most, those are just numbers. But to an astronomer, they are the heartbeat of a world in motion. That velocity means freedom. It means the object is not bound to the sun, not part of our cosmic family. Its orbit is hyperbolic, an open curve, a gesture of departure. Unlike the circular or elliptical orbits of planets and comets, a hyperbola never closes. It is the signature of something that comes once, passes briefly through our light, and then vanishes into the dark. And that's what made 3I Atlas so haunting. We were watching something we would never see again. You might imagine an object like that as a rock, cold and inert. But when the data began to accumulate, that image didn't fit. Its light curve, the way its brightness changed over time, revealed irregularities that spoke of shape and motion. It was tumbling, but not chaotically. Its rotation appeared deliberate, stable, even elegant. Some described it as a spindle, others as a flattened ellipsoid, turning slowly as it reflected sunlight in uneven pulses. Its surface albedo, the measure of how much light it reflects, was higher than expected for a comet. It shone faintly, but with a quality of metallic sheen, as if coated in something smoother than dust. And there was the matter of its acceleration. Astrometry had shown that the object was deviating ever so slightly from the path dictated by gravity alone. That deviation could, in theory, be explained by outgassing the release of vapor from within, like a comet heating under sunlight. But there were problems. The spectral data revealed almost no trace of water vapor, which should have been abundant in any ordinary comet. Instead, the dominant emissions were carbon dioxide, and in quantities that defied logic far too much for an object of its size, composition, or proximity to the sunday. So what, then, was causing the movement? Some suggested the object might be extremely low in density, more like a hollow structure than a solid body. If that were true, sunlight itself could push against it, the way wind moves a sail. The idea was controversial. It implied that 3I Atlas might be a kind of natural light sail, a wafer-thin fragment of cosmic material evolved to drift on starlight. But there was a problem with that too. For something so light, it should have tumbled erratically, like a leaf in a breeze. Instead, it rotated with an almost serene stability. It was as if some hidden balance kept it poised. The numbers whispered possibilities, and with them, unease. Imagine it, a fragment from another star system, perhaps 7 billion years old, passing through our own like a message carried on a cosmic tide. Its structure untouched by time, its surface recording the chemistry of worlds long gone. Each molecule within it had once belonged to a star that lived and died before our sun was even born. To study such a thing was like holding a piece of prehistory in your hands, except, of course, we could never hold it. We could only watch as it drifted past, indifferent to our questions. And yet, the more precisely we measured, the stranger it became. The models showed that its path through the solar system was unusually direct. Most interstellar visitors enter at random angles, their trajectories bent by the sun's gravity into wide arcs before they depart. But 3I Atlas followed a line that seemed unnaturally clean, almost as if it had been plotted. It entered the system at high inclination, dipped close to the sun, then curved away with minimal deflection. Its exit velocity, even after accounting for gravitational deceleration, matched its entry velocity almost perfectly. That kind of symmetry is rare in celestial mechanics. Nature, though elegant, is seldom so exact. There's a quiet moment in every scientific investigation when the data stops behaving like data when it begins to tell a story. And here, the story emerging from 3I Atlas was one of endurance. Whatever this object was, it had survived journeys that would have pulverized ordinary comets. The interstellar medium is not kind. It is a desert of radiation, dust, and magnetic fields that slowly erode anything that travels through it. Over billions of years, ice sublimates, rock fractures, metal corrodes, yet this object, though ancient, still held together, moving with the precision of a crafted thing. Some of the scientists began to speak of it in more poetic terms, a relic of a forgotten system, perhaps one that formed when the universe was young and full of fire. Its estimated age, derived from isotopic models, was around 7 billion years, older than our Sunday. It was, as one astronomer put it, a fossil of time itself. Others were more cautious. They pointed out that we know little about the materials that make up interstellar bodies. The void between stars may harbor forms of matter we have never encountered. What we interpret as metallic reflection could be exotic ice, hardened by radiation. What appears to be acceleration could be subtle interactions between solar, wind, and surface minerals. There are always natural explanations, if we search long enough. And yet, there's something about the way it moved, the grace of its passage, that resists indifference. It didn't tumble like debris. It glided, smooth and constant, as though shaped for the journey. The sun illuminated it briefly, and then it faded again into the black. It's tempting to imagine it as a messenger, not in the literal sense, but as a reminder of scale, of how small and temporary our world is against the canvas of time. Because here's the thing. When you trace its path backward, when you follow the geometry of its hyperbolic curve, it points toward no single star. Its origin is lost. It came from a region of the galaxy unmarked by any known system, a cold expanse where stars are scarce. That means it could have wandered for eons, crossing light years without aim. It might have been ejected from a dying star, or flung from the ruins of a shattered planet. Perhaps it had crossed interstellar space dozens of times before, passing through other systems unnoticed. Each journey would leave faint scars on its surface, micrometeorite impacts, radiation burns, the slow erosion of cosmic time. And yet, it endured. It is astonishing to think of such resilience. A fragment no larger than a mountain, carrying within it the chemistry of alien suns, traveling faster than anything humanity has ever built, untouched by any hand, unbent by gravity, passing through our solar system for a brief instant before disappearing forever. It humbles you, doesn't it? Because for all our technology, all our telescopes and theories, we are still creatures of one world, watching from the shore as the universe drifts by. The challenge for scientists, of course, was not only philosophical. The physical act of measuring something that fast, that faint, and that transient was a test of our instruments. The light curve changed too rapidly for some telescopes to keep up. Exposure times had to be adjusted, tracking algorithms rewritten. Even space-based observatories struggled to follow its path as it slipped through the glare of the inner solar system. Errors compounded easily. A tiny miscalculation in time could mean missing it entirely, but there was something poetic in that struggle too. To measure an interstellar object is to confront our limitations of time, of perspective, of reach. The scientists knew that every observation might be the last, every data point a goodbye. There would be no second chance, no orbit to bring it back. In the end, the measurements gave us an image not of form, but of essence, motion, reflection, rhythm. The numbers spoke of velocity and brightness, but beneath them was something else, something ineffable, the quiet persistence of a fragment older than memory. It reminded us that space is not empty but full of stories, and that each passing object carries one with it, whether we recognize it or not. And yet, as the observations deepened, the mystery only grew. The light coming from 3I Atlas did not behave entirely as expected. There were subtle variations in color temperature, small but consistent shifts in spectral lines that hinted at chemical oddities. Carbon dioxide? Yes, but something else as well, traces of metals that shouldn't be vaporized at that distance from the Sunday nickel, perhaps. And curiously, no sign of iron, which should have been abundant in any natural fragment of that size. Those findings would soon take the investigation down a new and even stranger path, one that moved beyond motion and into composition, beyond orbit and into origin. Because within the chemistry of that light lay a question that no trajectory could answer. What was this thing made of? And why did it not behave like anything we've ever known? The scientists would soon turn their instruments to the spectrum itself, to the fingerprints of light, where the true nature of matter reveals its secrets. And in doing so, they would find that 3I Atlas held within it not just the story of its journey, but the memory of its creation, a memory written in elements that shouldn't exist together, and yet somehow did. The first hints came not from the images, but from the light. You see, when you break light apart, it becomes a language, one that the universe has been speaking since the beginning of time. Every atom, every molecule, leaves a signature in the spectrum, a pattern of bright and dark lines that tells you what it's made of. And when the scientists turned that prism of analysis toward 3I Atlas, what they saw did not fit the grammar of nature as they knew it. The data came in quietly at first, faint bands of emission that appeared in the infrared and ultraviolet. At a glance, it looked like a typical cometary spectrum: carbon dioxide, a little carbon monoxide, a faint trace of hydrocarbons. But when they ran the ratios, something extraordinary appeared. The proportion of carbon dioxide to water vapor was 8-to-1, the highest ever recorded. For comparison, even the most volatile rich comets in our solar system rarely exceeded a ratio of 1-to-1. The implication was staggering. This object was venting carbon dioxide in vast quantities while producing almost no water at all. That single ratio told a story. It said that 3I Atlas was not made of the same stuff as the comets we know. It hadn't formed in a region rich in ice, like the outer solar nebula, but in a place where carbon compounds dominated a world of gas and dust, so cold and distant that water froze out of existence. In a sense, it was a fossil from a different kind of solar system, one with a chemistry alien to ours. But then came the second surprise, as the James Webb Space Telescope examined the object in infrared wavelengths. A new set of spectral lines appeared, thin, bright, unmistakable. They corresponded to nickel vapor. Nickel, of all things, shimmering in a faint, high-energy glow. That discovery stopped everyone cold. Nickel doesn't vaporize easily. It requires temperatures above 1,000 degrees Celsius, far beyond what sunlight could induce at that distance from the Sunday. And yet there it was, the spectral fingerprint of nickel, clear as day. The simplest explanation, of course, was that the data was wrong, that some reflection, some instrument artifact, had mimicked the lines. But the signal persisted across instruments, across days, across observatories. It was real. Something within 3I Atlas was releasing nickel into space at temperatures that could not exist there naturally. What made this even more perplexing was the absence of iron. Normally, where there is nickel, there is iron. The two metals are cosmic, siblings, forged together in the hearts of stars. Every meteorite, every planetary core, carries both in intertwined abundance. But 3I Atlas seemed to lack iron entirely. Its spectrum was clean, sharp, and strangely selective nickel, yes, but no iron, no chromium, no manganese. The pattern was too deliberate to be coincidence. That's when the first whispers began. Dr. Avi Loeb at Harvard, known for his willingness to chase unconventional ideas, proposed a startling possibility. The signature, he suggested, might not come from pure nickel, but from a compound nickel tetracarbonyl. It's an exotic molecule, NiCO4, composed of nickel, bound to carbon monoxide. On Earth, it forms only under specific conditions: high pressure, moderate heat, and an atmosphere rich in carbon monoxide. More importantly, it is not a naturally abundant compound. It's produced industrially, used in metallurgy to refine nickel. In human terms, it is a product of design. The thought hung in the air like a question no one wanted to answer. Could such a molecule exist naturally, in deep space, in quantities large enough to dominate a spectrum? Theoretically, yes, if a world rich in nickel and carbon monoxide had once existed, and if that world had somehow been destroyed, releasing its chemistry into the void. But the precision of the signature, its purity, was difficult to explain away. Some scientists tried. They proposed that the nickel lines could come from small meteoritic inclusions within the object, heated transiently by solar flares. Others argued that the lack of iron was an illusion, masked by overlapping spectral absorption bands. Every theory, though, required more assumptions than the last. The more they tried to make the data fit the familiar, the less familiar it seemed. And perhaps that's the point where science becomes something more than calculation, where it becomes confrontation. The data is not lying, but it is speaking a dialect we do not yet understand. You can imagine the atmosphere in the mission briefings at that time, the cautious tone, the long silences between sentences. Scientists are not prone to fantasy, but they are drawn to wonder. And this was wonder wrapped in restraint. Because if the nickel tetracarbonyl hypothesis was true, it suggested that 3I Atlas had once been part of a system where industrial chemistry, or at least complex thermochemical processes, had occurred. It didn't mean intelligence, not necessarily. It might simply mean that somewhere, sometime, nature had achieved order beyond our expectations. Still, the implications were too profound to ignore. Teams began reanalyzing the data, running laboratory simulations, attempting to reproduce the conditions under which nickel vapor could exist without iron. None succeeded. The temperatures required were too high, the absence of iron too absolute. Even exotic scenarios, lightning in a carbon-rich atmosphere, collision-induced, vaporization failed to match the ratios observed. And so, the mystery deepened. The comet, if that's what it was, seemed to carry a dual nature. On the surface, it was dust and carbon dioxide, faint and pale like any other interstellar fragment. But beneath that exterior, it seemed to hide a reservoir of metal, organized, pure, and reactive. When it approached the sun, it released that metal in vapor form, creating spectral lines that glowed faintly against the black. It was as if the object had memory, responding to sunlight the way a machine responds to a trigger. At that point, the discussions shifted from chemistry to history. How could such a composition come to be? One hypothesis suggested that 3I Atlas was the remnant of a planetary core, the inner layer of a world that had long since been stripped away. Over billions of years, as its parent system collapsed or was torn apart by gravitational tides, fragments of that world might have been cast into interstellar space. If that were true, then this object was literally a piece of a lost planet, its metals refined by geological processes now long extinct. But even that didn't quite explain the nickel. Planetary cores contain both nickel and iron, inseparable at the atomic level. To find one without the other defied the chemistry of planetary formation itself. Unless, of course, something or someone had refined it. That's the danger of discovery. Once the mind glimpses the extraordinary, it becomes difficult to return to the ordinary. Still, most of the scientific community resisted such leaps. They held to the discipline of skepticism, reminding themselves that extraordinary claims require extraordinary evidence. And yet, even in their caution, they couldn't shake the feeling that 3I Atlas was whispering of something beyond their models. Some nights, when the observatories were quiet and the data still streamed through fiber lines from telescopes orbiting Earth and Mars, the researchers would watch the numbers scroll across the screen, those spectral peaks and valleys, and wonder what story they were tracing. The object was 1 billion years older than the Sunday. It had seen the rise and death of stars. It had traveled through regions of the galaxy where life might have begun and ended countless times. Could it be, they wondered, that what they were observing was not just chemistry, but the residue of civilization itself, a trace of industry, long vanished into cosmic dust? No one said it aloud, of course, but the thought lingered. In truth, it didn't matter whether 3I Atlas was artificial or natural. What mattered was that it challenged our definition of what natural means. If the universe can assemble a compound like nickel tetracarbonyl without the hand of intelligence, then perhaps the distinction between nature and creation is thinner than we think. Perhaps intelligence itself is not unique, but emergent, a property of complexity that the cosmos expresses wherever it can. And that's the beauty of it, really. Each anomaly expands the boundaries of our imagination. Each unexplained signal reminds us that we are still students of a universe far older, far stranger than our equations can capture. The scientists continued their work, gathering more data as the object drifted farther away, its light growing fainter with each passing night. The ratios remained consistent. The absence of iron persisted. The nickel signature, unwavering. There was no error left to hide behind. Whatever 3I Atlas was, it was real, and it was unique. But as the weeks passed and the object receded into the outer dark, a new anomaly began to emerge, not in its chemistry this time, but in its appearance. Images from Hubble showed something impossible. A faint tail, a secondary plume of gas and dust, extending not away from the sun as expected, but toward it. It was as if the object's breath defied gravity, streaming backward against the flow of solar radiation. At first, it was dismissed as an illusion, a trick of perspective, but as more images arrived, the pattern held. The tail was real, a narrow, luminous line pointing straight at the Sunday, and with it, a new mystery was born, one that would once again defy explanation. Because, you see, in physics, tails don't move toward their light source. And yet, here was 3I Atlas, writing its own rule in the language of starlight. And so, as the object continued its silent journey through the solar wind, scientists found themselves staring at an image that made no sense, a comet whose tail pointed the wrong way. And in that impossible gesture, the story of 3I Atlas was about to deepen once more. The first image that revealed it came from Hubble, a streak of light so faint that most would have dismissed it as noise. But the astronomers, trained to notice the smallest anomalies, saw something that made them pause. The tail of 3I Atlas, that beautiful plume of gas and dust, stretching into space, was pointing the wrong way. Against every known rule of celestial mechanics, the secondary stream seemed to lean not away from the sun, but toward it, an inversion of physics that felt like a whisper from the impossible. Normally, cometary tails are among the most predictable features in astronomy. When a comet approaches the sun, heat sublimates its frozen gases, releasing jets of dust and vapor. Solar radiation pressure and the solar wind then sweep those materials outward, forming tails that always point directly away from the sunday. It's one of the few certainties of the cosmos, a dance choreographed by light itself, but with 3I Atlas, that choreography seemed to falter. The primary tail behaved as expected, faint but streaming outward in the classic fan shape. The secondary tail, however, defied it completely, angling toward the light like a defiant echo. At first, the observers thought it might be a visual illusion, an artifact of viewing angle or imaging saturation. After all, interstellar objects move swiftly, and long exposures can create deceptive trails. But as the hours passed and new images arrived from other observatories, the Very Large Telescope in Chile, the Gemini Observatory in Hawaii, the Mars Express orbiter circling high above the red planet, the anomaly persisted. The direction of that backward tail remained constant, even when viewed from entirely different vantage points. It was real. They called it an anti-tail. The term wasn't new. In fact, astronomers had seen similar phenomena before, though never quite like this. Some comets in our solar system have displayed temporary anti-tails, thin, spike-like features that appear to point toward the sunday. These are optical effects, caused when Earth's line of sight aligns with a comet's orbital plane, creating the illusion of a reversed tail, but those illusions are fleeting and depend on specific geometries. What made 3I Atlas remarkable was that the antitail persisted across multiple perspectives. It wasn't an illusion, it was an event. To understand it, we have to imagine the scene in 3 dimensions. Picture the sun at the center, radiating streams of charged particles outward in all directions. Now imagine 3I Atlas cutting through that flow, an interstellar wanderer entering the solar wind at tremendous speed. Its motion, its composition, even its electrical charge, all of it would interact with that wind in complex ways. Perhaps, some speculated, magnetic fields were at play. If the object carried a residual magnetic field, the charged particles in its coma could have been redirected, forming a tail that appeared to flow inward rather than outward. But magnetic fields that strong should have left detectable signatures: polarized light, auroral emissions, synchrotron radiation, and none were found. Others proposed a purely mechanical explanation, that the antitail was composed of heavier dust particles, which, unlike gas, were less affected by radiation pressure and instead followed a more ballistic trajectory along the object's orbital plane. The smaller particles would be blown outward, forming the normal tail, while the heavier ones, moving slower, would seem to cluster in the opposite direction, creating the illusion of an inverted stream. It was a convincing argument, at least at first, but the simulations didn't match the data. The antitail of 3I Atlas was too narrow, too coherent, too persistent. Dust disperses quickly in the solar wind. This structure remained stable for weeks. It was almost as if it were being maintained sculpted, even by some internal mechanism. And that, of course, was where the speculation began to darken again. What if the object was emitting not just gas or dust, but something else, a controlled jet, or a venting process that operated rhythmically against the natural flow? What if what we were seeing wasn't a passive reaction to sunlight, but an action, a choice made by something within the object's structure? Most dismissed that line of thought immediately. The cosmos is full of complex, self-organizing behaviors that mimic intention. Magnetic reconnection events, plasma instabilities, electrostatic feedback. Nature often creates patterns that look deliberate but aren't. And yet, 3I Atlas had already challenged so many expectations that even the skeptics felt uneasy brushing the idea aside. The more they studied the images, the stranger the geometry became. The antitail's angle shifted slightly over time, following what seemed to be a repeating cycle. Its brightness pulsed faintly, as though tied to the object's rotation period. When plotted on a timeline, the oscillations in light corresponded almost perfectly to the period of the object's spin, an 8-hour rhythm first identified through astrometry weeks earlier. It was as if the tail were breathing, in sync with its motion, responding to some hidden pattern deep within. You see, science is at its most human when it encounters what it doesn't understand. The data pours in, the instruments hum, and behind every screen is a person staring at numbers that refuse to behave. The Hubble team ran the analysis again and again. The James Webb images were reprocessed. The European Space Agency recalibrated its spectrographs. And still the antitail glowed, pointing toward the sun like a needle of light piercing the void. One physicist described it beautifully. It's as though the object is exhaling against the wind. That metaphor stuck, because, well, that's what it looked like. The primary tail, the normal one, streamed away obediently, pushed by the solar wind. The antitail, meanwhile, seemed to resist, to reach back toward the source of its illumination. It was almost poetic, this image of an interstellar traveler inhaling the light of our sun before continuing on its eternal voyage. From a technical perspective, the persistence of the antitail forced astronomers to reconsider their models of dust dynamics. It implied an extraordinary degree of coherence either in the material being emitted or in the way it interacted with sunlight. Some suggested that the dust grains might be electrically charged, aligning themselves along magnetic field lines, much like iron filings in a magnetic field. But to maintain that alignment over millions of kilometers would require a field strength far beyond anything naturally sustainable in such a small object. Others, more cautiously, proposed a hybrid model, that the antitail was a composite phenomenon, part optical, part physical. Perhaps a stream of larger particles was being ejected backward along the object's trajectory, while at the same time the geometry of observation amplified its visibility, making it appear brighter than it should. It was an elegant compromise, but, as with all compromises, it left something unresolved. You know, the beauty of science lies not in certainty, but in tension, that delicate balance between what we can explain and what still resists us. And 3, IAWN, with its reverse tail, was pure tension made visible. Every explanation led to another question, every hypothesis revealed a deeper strangeness. Even the most grounded scientists found themselves slipping into wonder, imagining possibilities that lay somewhere between physics and poetry. One of the more speculative analyses suggested that the antitail could be the remnant of an interaction to wake left behind by the object's passage through the solar wind, similar to how a boat leaves a trailing ripple on water. If 3I Atlas had an active surface, periodically releasing material through vents or fractures, those emissions might create turbulence in the plasma environment, forming temporary structures that mimicked a second tail. The problem with that, however, was timing. The antitail appeared too soon after the object's closest approach to the sun and lingered too long afterward. Whatever it wasn't fleeting. And so the enigma remained, shimmering faintly against the backdrop of the Milky Way. It's strange to think of it now that somewhere, billions of kilometers away, that inverted plume might still exist, stretching across space, invisible to all but the most patient eyes. It was a reminder that even the laws of nature, so absolute in our equations, can bend into mystery when confronted with the unknown. In a sense, 3I Atlas was teaching us humility. We had grown used to explaining everything to reducing beauty to mechanism and mystery to math. But here was something that refused to be tamed. A comet, a rock, perhaps something older and stranger, writing new equations across the sky. The final datasets from the campaign showed that the antitail began to fade as the object moved farther from the sun, its brightness diminishing until it vanished into the background noise. But the questions it left behind did not fade. They multiplied. If the antitail was real, if it truly defied solar radiation pressure, what did that say about the nature of the material being expelled? Could it have been magnetic dust, or metallic vapor, or something more complex, something engineered, perhaps, to interact with light in ways we don't yet understand? Most dismissed the last idea as romantic speculation, and yet, in private, some of the scientists admitted that it haunted them. The precision of the geometry, the persistence of the structure, it all felt too deliberate, too stable to be random. And so, once again, science found itself standing at the edge of its own reflection, torn between the rigor of skepticism and the pull of wonder. As 3I Atlas continued its long journey outward, away from the sun, the antitail faded completely from view. But its memory lingered, encoded in terabytes of data, in papers still, under peer review, in the minds of those who had seen it first. And as the campaign transitioned to its next phase, attention turned from its shimmering tales to the deeper question that had begun to echo quietly among the teams. If this was truly an exercise, a global campaign in the name of planetary defense, then why had it been triggered by an object that posed no threat at all? Why this one, and not another? What did they see in 3I Atlas that warranted such extraordinary coordination, such urgency, such silence? The answer, perhaps, was hidden not in the object itself, but in the decision to observe it. Because sometimes, what we choose to study tells us more about our fears than our hopes. And as the telescopes turned away from the vanishing light and the data analysts began their long review, a new question began to take shape, quiet, unsettling, and inevitable. Why this campaign, and why now? It was the question that quietly threaded its way through every discussion, every late-night briefing, every encrypted message exchanged between observatories. Why this campaign, and why now? The International Asteroid Warning Network had existed for more than a decade, and in that time it had catalogued thousands of near-Earth objects. Some had come close enough to cause alarm. Some had even warranted small-scale observation exercises. But never not once had the network mobilized on this scale for an object that posed no conceivable threat to Earth. 3I Atlas, after all, was already on its way out. It would pass the orbit of Mars, then Jupiter, and by the time the world had finished analyzing the data, it would already be gone forever. So why act as though the sky itself had sounded an alarm? The official reasoning, as always, was procedural. The activation of the campaign was described as a capability assessment exercise, a phrase that carried all the comfort of bureaucracy. On paper, it was a test of coordination, a way to evaluate how the network's systems would respond to a sudden interstellar detection. There was logic in that. After all, humanity had only seen 2 interstellar visitors before. Perhaps this was simply prudence, an opportunity to train on a real but harmless target, and yet, the deeper one looked, the less convincing that explanation became. If the purpose had been purely technical, the network could have chosen any number of candidates. There were near-Earth asteroids, slow-moving comets, even known space debris that could have served as perfect test cases, predictable, safe, and inexpensive to monitor. Instead, they chose the strangest object in the known sky, one that defied every category, every expectation. It was as if someone had gone out of their way to select the most enigmatic, most unpredictable target imaginable. Some suggested that perhaps this was deliberate, that the scientists at the core of the network had seen in 3I Atlas not just a training opportunity, but a mystery worth unraveling under the cover of procedure. Calling it an exercise might have been a way to bypass red tape, to free up funding, to coordinate telescopes that otherwise would have been locked into separate projects. If that were true, it was clever, a scientific sleight of hand disguised as routine. And yet, that theory only deepened the enigma, because what they discovered, and how quickly they reacted, implied that someone had been watching long before the official discovery date. You see, the timeline doesn't quite add up. The public announcement of 3I Atlas came on October 21, 2025. Yet internal memos from participating observatories reveal that preparation for the campaign began weeks earlier. Observation schedules had already been cleared, conference calls had been held. There were even references to pre-coordinated calibration protocols, the sort of arrangements that require months of planning. In other words, by the time the world knew the object existed, the machinery to observe it was already in motion. Now, that could mean foresight, or it could mean foreknowledge. And that, perhaps, was the most unsettling thought of all. Perhaps, well, someone knew it was coming, not because they detected it by chance, but because they had been tracking it long before it became visible from Earth. The idea sounds sensational, but in the age of classified telescopes and deep space monitoring networks, it isn't impossible. The world's space agencies and military satellites observe far more of the sky than the public ever sees. It's conceivable that 3I Atlas had been detected early by instruments not meant for scientific study, instruments that look outward for other purposes. Still, there was another, simpler possibility, that the campaign wasn't about the object at all, but about the response. The way humanity would organize itself when confronted with something unknown, unthreatening, but undeniably alien in origin. Perhaps the real experiment wasn't observational, it was behavioral. That notion began to circulate quietly among researchers as the campaign unfolded. What if this was a stress test for our global systems, a simulation of how we might react to a future event, one where the stakes were not curiosity but survival? The scale of coordination, the protocols, even the phrasing of the internal communications, all of it mirrored military readiness. And yet, unlike war, this mobilization came without fear. It was a rehearsal for a kind of planetary awareness. But there was one more layer, the one that no one wanted to speak of directly. Some believed the campaign might have had a second purpose, one hidden behind the language of defense. That 3I Atlas, with its strange chemical fingerprint and inexplicable tail, had drawn not just scientific attention, but strategic interest. After all, if an object truly defied natural explanation, if it carried to materials or patterns unknown to our solar system, it could represent more than a scientific curiosity. It could represent a resource or a signal. The thought is uncomfortable, isn't it? The idea that our first instinct, when confronted with something born between the stars, might not be wonder, but control. And yet, history suggests it would be so. Every new frontier humanity has faced oceans, continents, orbit, has begun with exploration and ended with possession. Why should interstellar space be different? In the weeks that followed the discovery, reports began to surface, quiet ones, unconfirmed but persistent, of satellites being retasked, of data being withheld. Certain observatories found themselves suddenly cut off from streams they had previously shared freely. It wasn't censorship, exactly. It was caution. And in that caution, you could sense something deeper, something that felt less like secrecy and more like fear. Still, for most of the scientists involved, the focus remained pure. They measured, they analyzed, they published what they could. For them, the campaign was a triumph of collaboration, proof that, when faced with the unknown, humanity could act as one. And perhaps that's true. But even unity can carry undertones of unease. Beneath the harmony of shared purpose, there lingered a quiet question. Unity for what? Imagine, for a moment, the conference calls, the voices from NASA, ESA, JAXA, the observatories of Chile and South Africa, the data analysts in Italy and Spain, each speaking in precise, careful language, yet each aware that something about this mission was different. There were protocols that didn't quite match previous exercises, data channels marked with higher clearance levels, requests for encryption where none had been needed before. The tone, one researcher later recalled, was half scientific, half classified. When pressed for explanation, the officials simply repeated that this was an international exercise in preparedness. Preparedness for what, however, was never stated. And that's the thing about science under systems of power. It often finds itself walking the line between curiosity and caution. On one hand, there's the thrill of discovery, the awe of peering into the deep unknown. On the other, there's the shadow of authority, the reminder that not all discoveries are meant to be shared. In that tension, 3i Atlas became not just an astronomical event, but a mirror reflecting how humanity responds when wonder meets control. Perhaps then, the question, why this campaign, doesn't have a single answer. Perhaps it was all of these things at once: a rehearsal, an investigation, a quiet test of coordination. A scientific endeavor wrapped in political caution. A mystery disguised as routine. Because sometimes, the best way to hide significance is to bury it beneath procedure. There's a phrase that appeared in several of the campaign's internal memos: coordinated anomaly response. On paper, it was a simple directive, the guideline for how to act when data deviates from expectation. But in practice, it felt almost prophetic. Because that's what 3i Atlas was: a coordinated response to an anomaly, a gathering of minds around something that refused to fit. You see, the deeper truth might be this: 3i Atlas was less a target of study than a question embodied. Its strange chemistry, its reversed tail, its precise motion, all of it conspired to remind us that we still don't know how to tell the difference between the strange and the significant. And perhaps the network, in its own quiet wisdom, recognized that. Perhaps it understood that the moment we stop reacting to anomalies, we stop growing. Still, one can't help but wonder about the motives that moved beneath the surface. The cost alone, millions of dollars, the diversion of telescope time, the global coordination suggests that something more than curiosity was at stake. If this truly was an exercise, it was the most elaborate one ever conceived. If it wasn't, then the alternative is far more intriguing. That the world's space agencies had glimpsed something in 3i Atlas that we were not yet ready to understand. And so, the campaign ended as mysteriously as it began. The object faded, the instruments powered down, the data was archived. Publicly, the operation was declared a success. The systems had worked flawlessly, the coordination had been seamless. But behind that calm summary lay something unsaid, a feeling shared quietly among those who had watched the light of 3i Atlas pass across their screens. It was the sense that the story wasn't over, that this had been the beginning of something larger, because, well, some events don't close, they echo. And this one, it seemed, would continue to reverberate in the papers yet unpublished, in the delayed data releases, in the whispered speculation that perhaps the campaign had revealed more than it was meant to. The world, of course, moved on. New discoveries came, new headlines replaced the old. But among the small circle of those who had truly seen the data, who had studied the object's motion, its chemistry, its impossible tale, there remained a shared question, unspoken but persistent. If the campaign had been, at least in part, a test, who exactly was being tested? Was it the object that had been under scrutiny, or was it us? That question would soon gain sharper edges, because as the months passed and the data began to circulate delayed, redacted, incomplete whispers emerged of something else. Military coordination, restricted transmissions, and data sets marked proprietary, even within scientific archives. It seemed that the strange and beautiful story of 3i Atlas was no longer only a tale of science. It was becoming something else, something that reached beyond astronomy and into the quiet corridors where knowledge meets power. And so, as the object slipped into the outer dark, leaving behind only its faintest echo in our instruments, the focus shifted once again, not on what 3i Atlas was, but on who controlled what we knew about it. Because sometimes the greater mystery is not in the sky above, but in the silence that follows it below. It began subtly, almost quietly, a shift in the tone of communication, a pause between updates, a delay in data releases that no one at first wanted to question. After all, delays happen in astronomy all the time. Instruments fail, calibration takes longer than expected, signals get corrupted by cosmic rays. But in the weeks following the close of the 3i Atlas campaign, those delays began to stretch into something else. Days became weeks, and entire segments of data were suddenly labeled as restricted. At first, the explanation was simple enough. The datasets were under embargo, pending verification. That's a common practice in the scientific world. Before results are made public, they undergo review, cross-checked, cleaned, and validated to ensure no false conclusions slip through. But this embargo was different. It wasn't just the raw data that went silent, it was the communication itself. The shared databases between observatories, normally transparent and accessible, became locked. Access requests were redirected. A handful of researchers found that their credentials no longer worked. You see, in open science, data is oxygen. When it stops flowing, people notice. And as that oxygen thinned, whispers began to fill the void. Some claimed that the U.S. Space Command had quietly retasked a series of classified satellites during the observation campaign, high-resolution instruments normally reserved for surveillance, not science. Others mentioned the involvement of defense agencies in Europe, coordinating under the guise of space situational awareness. The official reason given was banal, to avoid interference between observational frequencies. But among those who had been there, who had watched the sky for those long nights, the explanation rang hollow. It wasn't just the satellites. There were rumors of encrypted telemetry channels linking civilian observatories to military networks, something that had never happened before. For the first time, planetary defense and national defense seemed to overlap, their borders dissolving under the gravity of whatever 3i Atlas represented. The International Asteroid Warning Network had always been a scientific consortium, a collective born from cooperation and trust. Now it seemed to be evolving into something else, something quieter, more guarded, less human. And perhaps that's what unsettled people the most, because science, by its nature, is meant to be shared. Discovery is not ownership, it's illumination. But secrecy, even the kind that calls itself necessary, feels like shadow. Still, one must be fair, there are reasons for caution. The universe, for all its beauty, is not free of danger. An interstellar object entering the solar system at immense velocity could, in theory, behave unpredictably. It could fragment, emit radiation, or interact with solar fields in ways we don't yet understand. From a defense perspective, the unknown always carries risk. The involvement of military systems, then, might have been nothing more than precaution, to a way of ensuring that nothing was left unseen. And yet, the timing was too precise to ignore. Within days of 3i Atlas emerging from behind the Sun, orbital reconnaissance satellites began shifting their orientations. Communication arrays recalibrated. Even the Deep Space Network, NASA's crown jewel for interplanetary communication, restructured its schedule, clearing hours of bandwidth that were never publicly accounted for. To some, this looked like coordination. To others, containment. There's a phrase that appeared in several of the internal directives during this period: proprietary observation data. On the surface, it's a neutral term. It simply means that the information belongs to the organization that collected it. But in this case, proprietary took on a different weight. It meant inaccessible, classified, unseen. The term began appearing in documents that had nothing to do with commerce or research funding. It appeared in cross-agency memorandums attached to files containing spectral logs, positional data, and radio reflections from the object. To those within the network, it was a quiet betrayal of their ethos. Astronomers live by a simple creed: the sky belongs to everyone, No one owns a star or a comet or a shadow passing between them. To see that principle compromised, even in the name of caution, felt like a fracture in something sacred. Of course, not everyone agreed. Some argued that the situation demanded restraint. The world, they said, wasn't ready for unfiltered speculation. The strange composition, the reversed tail, the nickel vapor, these were anomalies, yes, but anomalies are not miracles. To release incomplete data would only feed hysteria, distort truth, and invite noise into the signal. Better to wait, to understand fully, before speaking. And so, the embargo held. But time has a way of eroding silence. Scientists talk, they compare notes, they notice patterns. And soon, fragments of information began to leak not through malice, but through curiosity. A few files, shared privately between colleagues, revealed unusual gaps in the datasets. Observation timestamps were missing. Certain ranges of wavelengths had been redacted. One particularly telling document listed instrumental interference correction for a period of 36 hours, a correction that, upon closer inspection, corresponded exactly to the time when the object's antitail was at its brightest. What kind of interference, one wonders, erases data so completely? Theories multiplied. Some thought the signal-to-noise ratio had been compromised by solar storms. Others suggested that the object might have emitted electromagnetic bursts that overloaded sensors. A few, bolder still, wondered if those corrections weren't errors at all but signals, patterns so unusual they were removed to prevent premature interpretation. No one could prove it, but the silence spoke louder than any denial. And yet, through all of this, one truth remained. 3I Atlas had changed something fundamental about how we see ourselves in relation to the unknown. Before, the line between science and security was clear. Now, it blurred. The night sky, once a realm of shared wonder, was becoming a matter of policy. Telescopes and satellites, once tools of discovery, were being folded quietly into the architecture of defense. Perhaps that's inevitable. Perhaps wonder and vigilance are two sides of the same instinct. But to those who had devoted their lives to the pursuit of open knowledge, it felt like a small dimming of the light. You know, there's an irony here. For centuries, humanity looked to the heavens to escape the divisions of Earth, to find perspective, humility, connection. But in the aftermath of 3I Atlas, the heavens had begun to reflect our divisions back to us. Data became territory, information became currency, and somewhere, hidden within the coded transmissions and embargoed archives, was the faint trace of a question we weren't ready to face. What if we had found something not proof, not certainty, but something that challenged our understanding of isolation? Would we tell the world? Could we? Perhaps that's why the military became involved. Not because they feared invasion, but because they feared reaction. Knowledge, after all, can be destabilizing. If the object truly carried signs of non-natural composition, even subtle ones, what would that mean for a species still struggling to understand itself? How would governments respond? How would faith or science or politics adapt? Sometimes the most dangerous discovery isn't a weapon or a virus, it's perspective. By December of that year, the embargo had become indefinite. Officially, the campaign's data was under extended review. Unofficially, it had disappeared into a labyrinth of classified archives. A few summary reports were released, sanitized, technical, strangely sterile. They spoke of successful coordination, minor anomalies, and no evidence of extraordinary phenomena. It was the kind of phrasing that closes doors rather than opens them. And yet, between the lines, you could sense hesitation. No evidence, after all, is not the same as no possibility. It's the language of careful omission of a truth half glimpsed, half concealed. Perhaps, in the end, the campaign wasn't just about watching the sky. Perhaps it was about learning how to handle what might come from it. because one day something will. It may not be Three-Eye Atlas. It may not even be in our lifetime. But someday, another visitor will appear, another interstellar traveler, bearing stories written in light and motion. And when that happens, we will once again have to decide what to see, what to say, and what to silence. And maybe that's what Three-Eye Atlas truly was, a rehearsal. Not for defense, but for discretion. A test not of our instruments, but of our readiness to face the unknown without fracturing. As the months passed, and the memory of the campaign faded from the headlines, a few of those who had been closest to it began to speak, cautiously, in lectures and papers. They didn't reveal secrets they couldn't, but their tone carried a new kind of gravity. One of them, a spectroscopist from Italy, ended her talk with a single sentence that lingered long after the auditorium emptied. "We looked at something that should not exist," she said, softly, "and for a moment we saw ourselves reflected in it." And perhaps that's the truth that matters most. Because in every great mystery, whether hidden by distance, by light, or by human hesitation, there's always a reflection of us, of our fears and our hopes intertwined. And as the debate over the withheld data continued, as whispers turned into questions and questions into quiet frustration, the focus began to shift once again away from secrecy and toward meaning. What does it really mean when science meets the limits of its understanding? What do we do when wonder collides with restraint? Those questions, still unanswered, would soon define the next chapter, the moment when the scientific community, caught between skepticism and possibility, began to confront not just the unknown in the sky, but the boundaries of knowing itself. You see, science has always walked a narrow line between what it knows and what it dares to imagine. Beyond that line lies a terrain both thrilling and treacherous, the realm where data ends and interpretation begins. And after the Three-Eye Atlas campaign, that line became a fault line. The embargoed data, the silences, the whispers of military involvement, all of it left the scientific community suspended between two truths, the official one and the one they felt in their bones. By the beginning of the following year, the debate had moved from observatories into conferences, from internal memos into quiet symposiums. It was never public, not quite. It unfolded in side conversations over coffee, in encrypted emails, in drafts shared only among trusted colleagues. The question wasn't whether something had been found, but rather what to do about the possibility that something might have been. Among those who had worked most closely on the campaign, a subtle divide had begun to form. On one side were the pragmatists, the scientists who believed in restraint. To them, the unknown must remain unknown until proven otherwise. They argued that speculation without verification was poison to reason, that wonder could too easily slip into myth. The other side, however, felt differently. They saw in Three-Eye Atlas a moment too rare to be buried under caution. The data might be incomplete, yes, but the patterns, the spectral irregularities, the reverse tail, the persistent acceleration were real. And real data demands interpretation. One evening, in a dimly lit lecture hall in Geneva, a small group of these more daring minds gathered under the guise of a routine workshop. They called it Anomalous Trajectories and Interstellar Objects, post-IAWN analysis. It sounded academic, harmless. But inside those closed doors, what unfolded was anything but routine. The meeting began with a presentation by Dr. Helen Park from Seoul National University, who had worked on the photometric analysis of Three-Eye Atlas during its perihelion phase. She stood before the dim glow of her slides, graphs, spectral lines, light curves, and spoke softly, almost reverently. "The object's light," she said, behaved as though it were aware of illumination. There was a murmur, a shuffle of disbelief. She clarified quickly, not metaphorically but physically. The reflectivity increased with solar incidence in a non-linear way too steep for any known material. It was as if the surface adjusted its albedo dynamically, reflecting more efficiently when exposed to greater intensity. She paused, then added quietly, "We have no model that explains this." A silence followed, the kind that hangs heavy with thought. The data, she insisted, had been verified. No instrumental errors, no calibration issues. The effect was subtle but consistent. If it were alive, she added with a faint, uncertain smile, I would say it was reacting to sunlight. No one laughed. The discussion that followed was measured but restless. They spoke of photonic response, of nanostructured surfaces, of self-regulating materials. A few suggested that under certain conditions, quantum coherence in metallic lattices might mimic such behavior, though no known natural process could produce those structures. Others remained cautious, pointing out that what appeared to be intelligence might simply be an emergent property, a coincidence of physics playing at design. But beneath all the talk of equations and hypotheses, there was something else in the room, a feeling that science rarely allows itself to name: awe. Later that night, when the session ended, a handful of them lingered outside in the corridor, their voices low, their tone conspiratorial. One of them, a veteran astronomer from Chile, said something that would echo through the months to come. "Perhaps," he murmured, "it wasn't us observing it. Perhaps it was observing us." He meant it half in jest, but no one replied. Back in their universities and labs, these scientists began to correspond in secret. They shared fragments of unredacted data, personal logs, observation notes salvaged before the embargo tightened. Out of those fragments, a clearer picture began to emerge. The nickel spectral lines, for instance those faint emissions that had caused so much confusion, were found to fluctuate in intensity with an 8-hour cycle, matching the object's rotation period. That meant the emission wasn't uniform, it was localized. It came from specific regions on the surface, as if from vents or arrays. Even more perplexing, the nickel signature wasn't static. Over the course of several days, its frequency shifted ever so slightly, a redshift, so consistent that it suggested motion relative not to the sun, but to the object itself. Something, somewhere on 3I Atlas, was moving. It was around this time that the term active region began to appear in their correspondence. The phrase had precedent in solar physics. Active regions on the sun are places of magnetic turbulence, where flares and prominences erupt. But here, the term felt different, heavier. An active region on an interstellar object implied process, maybe even function. To the pragmatists, these patterns were just noise dressed in narrative. But to the others, the ones who listened between the lines, it felt like a whisper from something ancient. And then came the incident that would fracture the silence completely. In early March, an amateur radio astronomer in Argentina, a retired engineer named Diego Morales, reported a strange signal in his recordings. He wasn't looking for anything unusual. He was tracking the residual echoes of 3I Atlas as it moved beyond the orbit of Jupiter. But one night, his receiver picked up a series of faint, narrowband emissions pulses, evenly spaced, at frequencies corresponding exactly to the nickel emission lines identified months earlier. The signal lasted less than 5 minutes, then vanished. Morales thought it was interference, perhaps a satellite ping. But when he checked the timestamps, he realized that every pulse was separated by exactly 8 hours. 8 hours, the same rotation period. He published his findings on an amateur astronomy forum, expecting little attention. Within days, his post was taken down, his account was deleted, and the next week he received a polite but firm visit from 2 officials claiming to represent the Argentine Space Agency. After that, he stopped speaking publicly altogether. But the data, a single screenshot of his spectral readout, survived. It circulated quietly among the same scientists who had once gathered in Geneva. And when they overlaid Morales' signal with their own archived data, the alignment was undeniable. The object had emitted something, faint but structured, and no one could explain it. Now, you might ask, could it have been coincidence? A glitch? A terrestrial echo? an error in calibration. Perhaps, but coincidences, when they multiply, begin to lose their innocence. What if 3I Atlas wasn't simply passing through? What if its trajectory, that perfect hyperbola, that clean entry and exit, wasn't just the product of chance, but intention? It's a dangerous thought, that word, intention. Science avoids it for good reason. Intention implies agency, and agency implies origin. But as more anomalies surfaced, the light variations, the spectral shifts, the rhythmic emissions, the idea began to creep in at the edges of the discourse, like dawn light seeping under a door. By late spring, several researchers had drafted a private paper titled Non-Uniform Photometric Response in Interstellar Object 3I Atlas, Implications for Active Surface Processes. It was never published, never even submitted, but those who read it described it as equal parts meticulous and unsettling. The authors stopped short of suggesting artificiality, but their conclusion was unmistakable. 3I Atlas exhibited behavior inconsistent with inert celestial bodies. One of the closing lines, written almost as a whisper, read, "If we are seeing what we think we are seeing, then observation itself may not be unilateral." And that, perhaps, was the most haunting idea of all, that the act of looking up might not be one way. As the months went on, the world forgot. Headlines moved on. The object faded from telescopes and from memory. But for those few who had seen the data, who had stared into that pale, shifting light and felt the echo of something greater than science, the question remained. What if, for the first time in human history, the universe had looked back? They couldn't prove it, they couldn't say it aloud, but quietly, in the margins of their notebooks, in encrypted exchanges that history will likely never record, they began to build something new, a framework, a conversation, a philosophy. Because if 3I Atlas had truly been more than stone and ice, if it had been a relic of intelligence, then it meant we were no longer alone in the narrative of creation. And that realization, fragile, beautiful, terrifying, would become the seed of a new discipline. A science not of defense, nor discovery, but of dialogue. For the first time, they began to speak of it not as an object, but as a presence. And as the idea spread quietly through the circles of those who still dared to wonder, a new question began to take shape, one not of physics, but of meaning. If something out there had noticed us, what story would it see when it looked back? That question, whispered like a prayer in the aftermath of 3I Atlas, would lead them and us toward the next revelation.